Today we're going to talk about another factoring method. Both of these are talking about cubes. One is sum of cubes, the other is difference of cubes. The equations for both are very similar. So let's take a look at them. First, sum of cubes. So what that means is we have cubes like this. We're able to cube the first piece, cube the second piece, and they're being summed together. The other one would look like a cube minus another cube, so numbers that we can take the cube root of, or terms we can take the cube root of. So we have sum and we have difference. Now the equations themselves are very similar. And I'm going to write them down. So it goes a and b, and I'm going to leave blanks. A squared, ab, and b squared. For this one, same thing. ab, a squared, ab, and b squared. So as long as you can remember that, the signs in between are what are going to get filled in, and we're going to use a new acronym that we're about to learn. It's called SOAP. So down here, I'm going to go ahead and write SOAP. And what SOAP stands for is same, opposite, always positive. These tell us what symbols go in the blanks. All right, as long as you can remember the pattern of A, B, A squared, AB, and B squared, we look at the original. So we're going to remember the word SOAP in our mind here. So I'm going to pull this up. We look at this. If it's sum, we're going to follow the SOAP acronym. Same sign. So in the first blank goes the same sign. In the next blank goes opposite sign. So opposite of plus would be minus. And the last one is always positive. Let's apply the same thing for when we have a difference problem. So subtraction. So same, opposite, always positive. So if you can remember where the letters go, the symbols themselves go with the acronym SOAP. So just something to help you out, or you could just memorize these equations, how they are. This one being the sum, and the other one being the difference. Okay, so I usually remember where the letters go and then use SOAP to figure out the signs in between. Okay, so let's actually apply this to our first problem. So for example, we want to go ahead and factor. Remember, factor just means get to an answer with parentheses. We want to factor the following: x cubed plus 8. Now I look at this problem and I know I can use cube method somehow, because we look at it piece by piece. So we'll call this A and this part B. Can I take the cube root of the first piece? Let's see. Can I take the cube root of it? Yeah. The number or the term that breaks up x to the third into 3 of the same pieces, something times something times something, would be an x. So A is x. Now B, can I also take the cube root of this number? What times what gives me 8? And that number would be 2. So yes, I can cube the first piece, I can cube the second piece, and then we look. It's going to be sum, and we use SOAP for that part. So I remember from before that my actual equation, a, b, a squared, ab, b squared, and then using SOAP according to my original piece, same sign, opposite sign, always positive. And now let's take the a and the b and plug them in. So a is x plus b is 2. A is squared, that would be x squared, minus a times b, x times 2, if we rearrange that, is 2x, plus b squared, that's 4. And there you go, you have factored it, and that's as far as you need to go. So just plugging things into the equation. If you don't trust it, you can multiply this all back out, and you would get the original problem. That's all you need to do to factor it. All right, let's try another one. 27 x to the third minus 125. So when you see the two pieces like this and you see an exponent 3, we're thinking about using cubes. Now, can I break this first term into 3 equal pieces, 3 of the same pieces? So 27, what times what times what gives me 27? That would be a 3. Does x to the third break into 3 pieces? Yes, that's x times x times x. See, that's what it will break down to, so my a value is 3x. We just write it once. Now the 125, is there something that what times what times what gives me that? That would be a 5 times a 5 times a 5. So my b value is 5. And then to help us fill out SOAP, we have the minus sign here. So writing the equation, I remember there's an a and a b, an a squared, an ab, and then a b squared. And following SOAP, same sign, opposite sign, always positive. So let's plug in what we have. So the a's and the b's now. A is 3x minus b is 5. A squared, so I need to square this whole thing. So it goes to both. It's going to be a 9x squared plus a times b. So a times b, 3x times 5 is a 15x plus b squared, 5 squared is 25. And there we go. We have our factored answer again. And we're done for now. Now, if this said to solve, we would have it set equal to 0, and we would be able to go a little farther than that. All right. For example, 192 x to the third minus 375 y to the third. They want us to factor that. So again, when I have two pieces and I see the exponent of 3, I'm trying to use either sum or difference of cubes. In this case, it is difference. Let's see, 192. Is there a number that would multiply to give me 192 3 times? So if I think about it, I look at my calculator. I don't know that one off the top of my head. 5 times 5 times 5 is 125. Let's try the next one up. 6 times 6 times 6, 216. So if 5 cubed makes 125 and 6 cubed makes 216, I need something in between, so it's a decimal. Can't really do a decimal on this problem. So if we run into a problem like this, maybe what we need to do is change these numbers around. Let's try a GCF first. Let's see if we can share any numbers and factor it out. And what actually factors out of both a 192 and a 375 would be a 3. So we're going to divide out a 3 from both. So now we're mixing and matching our factoring methods. 192 divided by 3 leaves us with a 64. Still have the x cubed minus 375 divided by 3 is a 125. Still have y cubed. And now let's see if we can use cubes in here. What times what times what gives me 64? That would be a 4. So 4 times 4 times 4. X cubed breaks into x and x and x. 125 we've seen before. That's a 5, 5, 5. Y cubed breaks into y's. So my a value is 4x. My b value, my b value is 5y. So there's my a, there's my b. Let's now plug that into our equation. Remember, it goes a and b, a squared, a times b, and then b squared. Using SOAP on my original here, it's subtraction, it's difference. So same sign, opposite sign, always positive. Let's plug it in. 4x minus 5y. All right, square a. So we got to square both. So that's 16x squared. A times b, 4 times 5 is 20. We still have an x times a y. Plus b squared, square both, the 25 and the y. Now we're really close. We just forgot something from above. We factored out that 3 earlier, so we still need that 3 in front here. And this now is your fully factored answer for another difference of squares. Sorry, difference of cubes. Cubes. All right, so this is difference of cubes. Again, the equations are very similar to each other. The a's, b's, a squareds, a times b, and b squared all go in the same order, but then you SOAP according to their original sign in order to fill out the rest. Same, opposite, always positive. Same, opposite, always positive.